Good morning, one and all. Today we're going to study about instruction, execution, and straight line sequencing. In the last class, we have seen how instructions are executing, how assembly language is. Okay. Today we're going to study about how instruction is being executed and straight line sequencing means a sequence of execution of your instructions. Now, see in this diagram, we're going to study this one. This is an exam. See, a plus b arrow goes to c. What does it mean? Add value of a and value of b, and result will be stored in a c, isn't it? Is the main operation of this instructions. Okay, how it's gonna execute? So this is your image. This is your memory, isn't it? So in the memory, first of all, what we are having your instruction as well as your data, both things we are having in a memory. First of all, this block, whatever these blocks are there, these blocks are reserved for code. Means this is a segment, program segment part. Okay, program segment part means, so in this block we are only storing instructions. We are not storing any values. Got it? We are not storing any data. Just we are inserting only instructions, full instructions, move, add. Okay. So here I'm not getting any value of A and R. So value will be stored in these blocks. Data for program. This is the data. This is the program. So whatever the value, for example, if I want a value of A, so the value of A must be in this section or in this blocks. We can get value of B here 20. I'm taking example, assuming these values. So isn't it? So these blocks are segmentation part, segmentation for program. In these blocks, we are getting only instructions, but in these blocks we can find values or we can actual data of those variables, isn't it? So this type of memory can be organized. Okay, if I want, suppose if I want one instruction, so that instruction must be present in these blocks only. Okay, if I want value of any variables, at that time those variable value must be get from these blocks only. Okay, this type of segmentation, or we can say this type of partition of your memory. So memory can be partitioned like this. These are reserved for only instruction purpose, and these are reserved for only a data storing purpose. Okay, depending on your memory, you can store a specific data in those blocks only. Okay, now we will see first how this instruction is to be executed. Okay, take this example. First of all, as I told you at the beginning, whatever first in the memory, your instruction will come to execute. So if I'm having a instruction like move a comma move a comma r, this is my instruction. First of all, if I want to execute these instructions, so in the processor, as I told you, we are having a PC. PC means what? program counter, isn't it? Why we are using that PC? Anybody? Okay, this is using to get a next executing instruction address. So this PC holds address of next execution instructions. Suppose if my next instruction is this one. Okay, so at that time, while executing move a comma r not, at that time this PC holds next instruction address, means this address. Suppose your move is at here and add is suppose here. Okay, first of all, before executing anything, first PC will hold the address of this move. So when I start executing move instruction, the PC will be incremented by its next values. For example, if it is in a this way, here the value is address is 1004. At the time your PC holds next instruction address, so automatically this will become 1004, isn't it? So PC is used to hold the address of next instruction which is to be executed next, isn't it? Okay, whenever the PC holds this address, the that respected instruction will come into the processor. In which register? IR register, instruction registers. Already I have told you about these registers. You have studied. So IR means instruction registers. So currently IR holds a current execution instruction. Currently, if I am executing move, this first instruction, move a comma r. So at that time your PC will become incremented by 4. At that time PC holds next instruction address, that is 1004. Okay, now you are executing move a comma r naught. So to execute these, what we need? I need a value of a first of all. Okay, I need value of r naught. In the r naught, here I don't have any value. So at that time we have to move a value into r naught. So where is a? Suppose your a is here. Here a. Okay. So value of a is 20. Just imagine. Here I am storing only instructions. Here I am storing only values or data. Already have explained about memory. Here this is the program segment block. This is the data block, isn't it? So now this value a will be moving from memory into the register. Which register? R0. So now R0 will become 20, isn't it? Okay, now this processor will check next instruction. So at that time it will go to PC holds which address? Next instruction address, that is 1004. So that is add this instructions. Imagine this is your next instruction. At that time that value will be, that instruction comes into IR again. Now IR holds, remove this, IR holds second instructions, add R1 comma R. Okay, while executing this instruction again your PC will become incremented. Why it is incrementing? Because of it needs to access next instruction. At that time your PC will goes to next instruction. So next instruction address is 1008. Are you understanding? Okay, now what is happening? Adding. What I am adding? I'm adding R1, value of R1 into R0, and again value result will be storing in R0. Okay, now my R1 is, suppose your R1 is 10. At that time 10 plus 20, 30. So 30 again will be stored in a R0, means whatever the R0 value is there, earlier value, so previous value will be deleted and your new result will be added, moved into that R. So now R0 become 30. Isn't it? This way your program will be executing. Okay. Here he has taken this example. C arrow value of A plus value of B. Okay. So value is A. For example, my A is here, B is here. These two values will add, and again result. Whatever result will be stored in here. Okay. See here somewhere in this position. Isn't it? Any doubt? Here you have to remember PC and IR, program counter and instruction register. Program counter is used to what? It holds the address of next instruction which is to be executed, and IR holds the current instructions. Okay, what you are executing current instruction, that is held by IR register. Got it? Any doubt? So this is a sequence way. What I am doing, I am executing sequence way only. Sequence means one by one. If suppose I want to jump to, for example, suppose I'm executing one by one instruction. Suddenly, I want to go to jump to this instruction, means this memory location. At that time, how is this to be executed? Sequentially means we can easily increment my PC value into 4, 0, 4, 8, 12. I can increment it by 4. Okay, easily I can get next values. If I want to jump from here to here directly, at that time, what I should do? So for that, we are having a branching. So branching means what? If I want to go from one branch to other branch, means one sequence to other sequence, at that time, this branching will come to use. Okay, so that we will see. Need out.